If our guests will take their seats, the hearing will come to order. Good morning to everyone, and welcome to today's hearing on effectively transforming our electric delivery system to a smart grid. I'd like to welcome our expert panelists who will discuss both the role of the federal government and industry stakeholders in transforming our power grid. Even today, with tremendous advancements in technology, electrification is considered the greatest engineering achievement of the 20th century. However, parts of this infrastructure are nearly a century old, and our increased reliance on electrical power is straining our system's capacity. In the past 9 years, we've experienced 3 big blackouts. It is estimated that the blackout of 2003 resulted in a $6 billion economic loss to the region. In order to improve efficiency of power delivery and incorporate renewable energy technologies, we need to modernize our grid infrastructure. A smart grid is a sophisticated two-way communication system for managing our electric infrastructure. It will operate more efficiently and reliably and empower consumers to more actively engage in energy use decisions. The technology to encourage their participation in these decisions will be at their fingertips. Accurate and timely price signals will help consumers reduce energy consumption during peak demand when prices are highest. This shaving off of the peak load, in turn, offers power plant operators the opportunity to avoid investment costs for new generation capacity. In addition, utilities will be better equipped to manage their systems and integrate energy from renewable sources, plug-in electric vehicles, and other storage technologies. Also, there's growing recognition that a smart electric grid is extremely important for responding to environmental problems such as ocean acidification and lethal overheating of our planet. More efficient energy production and increased use of renewable energy resources will help to set us on a course to address these environmental challenges. I'd like to thank the witnesses for their participation today. I'm looking forward to your testimony. I'm sincerely excited and interested in this, as I think so many of us are, as it's going to be central to solving our nation's energy problems, and we have an outstanding panel of experts. With that, I'd yield to our distinguished colleague and my friend, Mr. Inglis, for an opening statement.
Thank you, Mr. Chairman, and thank you for this very important hearing. At our last hearing, we discussed obstacles in getting renewable energy, wind and solar in particular, into the electricity market in a meaningful way. One of the biggest gaps we heard about was getting renewable energy onto a grid designed for centralized generation from conventional power plants. In order to move away from fossil fuels, we need to update the grid. A smart grid presents many exciting opportunities. First, we'll be able to use distributed generation to supply our population centers, enabling a shift toward renewable power. Second, we'll improve efficiency and increase capacity on the electricity grid. Finally, we'll create a new model of consumer participation. With the two-way communication made possible by smart grid technologies, consumers will have access to new information about their energy use and prices and get more involved in how they use electricity. So now we have to figure out how to get to a modern electricity grid. I'm looking forward to hearing from our witnesses about where we are now and where we have to go. Governments and professional associations will certainly play an important role in the research and development of smart grid technologies and in setting the standards that will govern the new electricity delivery system. Private enterprise will step in with cutting-edge technology designed to integrate the grid, better manage peak loads, and give consumers the tools they need to make informed decisions. I have several questions about the smart grid. We're working on developing a new grid and a new pattern of energy generation at this time. I hope to learn how these efforts are working in tandem and if we're going forward at the right pace. I also wonder what the proper relationship between private and public investment is in a project like this that serves both interests together. Finally, the smart grid will support electricity from sources far away from population centers. While this will support development of renewable electricity, it may also support continued reliance on old and polluting coal facilities that operate in the same remote areas. I hope we can address these concerns today, and I thank the Chairman for holding this hearing.
Thank you, Mr. Inglis. If there are other members who wish to submit additional opening statements, your statements will be added to the record at this point. It's now my pleasure to introduce our witnesses at this time. Ms. Patricia Hoffman is the Acting Assistant Secretary of the Office of Electric Delivery and Energy Reliability at the Department of Energy. Ms. Suedeen, am I pronouncing it right? Is it Suedeen or Suedeen? Suedeen G. Kelly is the Commissioner of the Federal Energy Regulatory Commission. Dr. George Arnold is the National Coordinator for Smart Grid Interoperability at the National Institute of Standards and Technology. Mr. Paul Martini is the Vice President of Advanced Technology for Southern California Edison. Mr. Jeff Ross, Executive Vice President for GridPoint Incorporated. And finally, Mr. Michael Stoessl is the Group President of Cooper Power Systems. We thank you all. As I think you've been briefed by staff, we try to keep the testimony as near to 5 minutes as we can. As my distinguished friend Dr. Ehlers used to say when he chaired the committee, as you go past 5 minutes, there's a risk the chair drops out from under you and you don't get to testify for the rest of the hearing. But I know it's difficult to keep these comments brief, but we sure appreciate your testimony. And following your comments, then we'll have a series of questions from the panel members. So with that, we'll start with Ms. Hoffman from the Department of Energy. Thank you. Please begin.
Thank you, Mr. Chairman, and members of the subcommittee for the opportunity to provide an update on the current status of smart grid activities at the Department of Energy, as well as future directions and priorities. The Energy Independence and Security Act of 2007 and the American Recovery and Reinvestment Act expanded the role of the federal government substantially in research, development, demonstration, and deployment of smart grid technologies, tools, and techniques. To fulfill this role, the Department of Energy and the Office of Electricity Delivery and Energy Reliability are carrying out smart grid activities in 3 primary areas: smart grid investment grants, smart grid demonstrations, and smart grid research and development. One of our top priorities is to responsibly disperse funds made available under the Recovery Act to develop and deploy smart grid technologies designed to modernize our nation's electric system. On June 25, 2009, we released 2 funding opportunity announcements, one for smart grid investment grants and the second for smart grid demonstrations. We are expecting to evaluate hundreds of applications over the coming months and to make awards for projects that will show the benefits of a more modern grid that uses smart grid technologies, tools, and techniques for the betterment of electricity consumers across America. We expect this funding to spark innovation, create businesses, provide jobs for American workers. We believe these programs represent a once-in-a-generation chance for game-changing investments, and we are dedicated to make sure that the American taxpayers get maximum value for these investments in terms of a more reliable, secure, efficient, affordable, clean electric system. While these programs are about transforming the delivery and management of electric power through the applications of today's smart grid technologies, tools, and techniques, such as phasor measurement units and advanced metering infrastructure, we are simultaneously working on next generation systems for expanding the capacity and increasing the flexibility and functionality of the electric transmission and distribution system. Our fiscal year 2010 budget request for smart grid and related R&D is aimed at harnessing the nation's scientific and engineering talent in electric systems and focusing it on discovery and innovation for new materials, algorithms, concepts, and prototypes for power lines, substations, transformers, storage systems, and power electronics. Section 1302 of the Energy Independence and Security Act directed the Secretary of Energy to report to Congress concerning the status of smart grid deployments nationwide and any regulatory or government barriers to continued deployment. This week, the Department of Energy released its Smart Grid Systems Report. The report finds that while many smart grid capabilities are emerging, penetration levels for substation automation, smart metering, distributed generation technologies are growing significantly. A part of the vision for smart grid is its ability to enable informed participation by consumers, making them an integral part of the electric power system. With bidirectional flows of energy and coordination through communication mechanisms, a smart grid should help balance supply and demand, enhance reliability by modifying the manner in which consumers use and purchase electricity. These modifications can be the result of consumer choices that motivate shifting patterns of behavior and consumption. These choices involve new technologies, new information regarding electricity use, and new pricing and incentive programs. A key aspect for the implementation of smart grid technologies is the need to address interoperability and cybersecurity. Development of industry-based standards for governing how the many different devices involved in a smart grid can communicate and interoperate with each other in a seamless, efficient, and secure manner is one of the top priorities for DOE and other federal and state agencies. Since the smart grid vision involves two-way flow of information and electric power for higher degrees of automation and control than what exists today in the electric transmission and distribution system, it is necessary for there to be standards that guide manufacturers and smart grid developers, foster innovation, and provide a platform that enables a wide range of offerings to come to market and have the opportunity to compete. As what occurred with the telecommunications and the evolution of the Internet, effective standards form the basis upon which entrepreneurs can bring innovations to the marketplace, build new businesses, create job opportunities. The public-private partnerships on phaser measurement units has been instrumental in the development and deployment of technology and the formation of the North American Synchrophaser Initiative. The Synchrophaser Initiative is an important technology to provide greater insight into system operating conditions and holds the promise to enable better indication of grid stress, as well as other performance characteristics. An important goal is to use the PMU-derived information to trigger corrective actions and maintain a reliable system operation. This concludes my statement, Mr. Chairman. Thank you for the opportunity to testify. I look forward to answering any questions you or your colleagues may have.
Thank you, Ms. Hoffman. Ms. Kelly.
Thank you, Mr. Chairman and members of the subcommittee for the opportunity to testify today. My name is Suedeen Kelly. I'm a commissioner on the Federal Energy Regulatory Commission. And what I'm going to do now is describe FERC's efforts to develop and implement a range of technologies which has come to be known collectively as the smart grid. I'm going to discuss three topics: our authority to act, the coordinated efforts we have undertaken to date with other federal regulators and state regulators, and the activity that we've undertaken on our own. Regarding our authority to act, it derives from two statutes: the Energy Independence and Security Act, passed in 2007, and the Federal Power Act, which has been with us for over 70 years now. The Energy Independence and Security Act gives FERC authority in the area of interoperability standards for the smart grid. The Federal Power Act gives FERC jurisdiction over part of the electricity industry and part of the electricity market. Specifically, there are three areas under the Federal Power Act where we have jurisdiction that are relevant to smart grid development. First, we have jurisdiction over the transmission of electricity by public utilities, but we don't have jurisdiction over the distribution of electricity, which is subject to state regulation. We have jurisdiction over the wholesale sales of electricity in interstate commerce by public utilities, but we don't have jurisdiction over retail sales, which is under the jurisdiction of state regulators. And we have jurisdiction over the approval and enforcement of reliability standards for the bulk power system. We have been coordinating over the last 2 years with federal and state agencies. In the federal arena, smart grid efforts involve a broad range of government agencies, and the federal agencies include primarily those who are with you today: the Department of Energy, the National Institute of Standards and Technology, and FERC. As Ms. Hoffman has described DOE's role on smart grid, and Dr. Arnold will soon describe the role of NIST. NIST will be involved in setting up a framework for interoperability standard development and overseeing that development. Once FERC determines that NIST's work has led to sufficient consensus regarding a standard, then FERC's role under the Energy Independence and Security Act is to adopt the interoperability standards, quote, needed to ensure the functionality and interoperability of smart grid. So it may be that some of the standards developed through the NIST process will not ultimately fall into the category of needed to ensure the functionality and interoperability. But to the extent those standards do fall into that category, it's FERC's responsibility to adopt them as regulations, or at least we have the authority to do that. Development of the interoperability framework, as Dr. Arnold will discuss, is a very challenging task. Recent funding for NIST efforts will help, but coordination among government agencies as well as among industry participants is just as important. DOE, NIST, and FERC have been working with each other to ensure progress, and those efforts will continue. In the state arena, as I mentioned, utilities are regulated by FERC at the transmission level and the wholesale level, and most of them are also regulated by one or more state regulatory commissions at the distribution level and the retail sales level. Now, because smart grid technologies span the grid from the transmission through the distribution level, the concurrent jurisdiction of federal and state regulators, we believe, will best be served if both federal and state regulators adopt complementary policies to avoid sending regulatory signals. To address this, as well as other issues related to deployment of smart grid technology, I and Mr. Fred Butler, who is chairman of the New Jersey Public Utility Commission, as well as president of the Association of State Utility Commissioners, formed a collaborative, and we co-chair that collaborative between FERC and the state commissions. At present, there are 21 states that have become a member of that collaborative. Since its creation 15 months ago, the collaborative has explored a host of technological and regulatory issues involving the smart grid, including the development of a clearinghouse of information at the Department of Energy, as well as the drafting of criteria that we suggested to the Department of Energy for the funding of smart grid technologies under the stimulus bill. And we are now participating with the help of Lawrence Berkeley Lab and the Pacific Northwest National Lab in the NIST process as a collaborative and in the development of DOE's clearinghouse for information from smart grid demonstration projects. A critical issue as smart grid is deployed is the need to ensure grid reliability and cybersecurity. FERC can use its existing authority to facilitate implementation of smart grid under the Federal Power Act. Last week, FERC adopted a smart grid policy statement that basically has two parts. The first part identified priorities that we see from our position of regulator of the electric industry for the development of interoperability standards. Cybersecurity is one of those priorities, as is standardized communication across intersystem interfaces. We also listed 4 functional priorities: wide area situational analysis, demand response, electric storage, and electric transportation. The policy statement also specified certain cost recovery mechanisms available for recovery of costs of transmission-owning utilities that want to invest in the smart grid facilities. I appreciate the opportunity to testify today, and I'd be happy to answer any questions that you might have.
Thank you, Ms. Kelly. Dr. Arnold.
Chairman Baird, Ranking Member Inglis, and members of the subcommittee, thank you for this opportunity to discuss NIST's progress in accelerating the development of standards needed to realize a secure and interoperable nationwide smart grid. Working with industry, government, and consumer stakeholders, NIST is providing strong national and technical leadership to help make a reliable, robust smart grid a reality. The Recovery Act provided NIST with $10 million from the Department of Energy, and we are using this funding to speed up the process to build the standards foundation for the smart grid. First, I'd like to summarize our 3-phase effort to expedite development of this foundation. Phase 1 is well underway and nearing completion. On the basis of stakeholder input, we have identified an initial slate of 16 standards, and 64 more are undergoing public review. In September, we intend to issue for public comment Release 1.0 of the NIST Framework and Roadmap for Smart Grid Interoperability Standards. The document that we deliver to FERC will describe a reference architecture, an initial set of standards to support secure and interoperable implementation, and prioritized action plans to fill gaps. In Phase 2, which we launched last month with a request for proposal, NIST is establishing a formal standards panel, a private-public partnership to drive long-term progress in the development and implementation of the hundreds of standards that eventually will be needed. Later this year, in Phase 3, NIST will announce plans for a framework for testing and certifying how standards are implemented in the smart grid devices, systems, and processes. As we work with the many stakeholder groups, we are uncovering and addressing many issues that are impediments to a fully operational smart grid. For example, there is a foundational smart meter-related standard that is so feature-rich that different meter vendors have implemented it in different ways. This ambiguity undermines interoperability. We have commissioned a fast-track effort to revise the standard and to ensure upgradability to extend the useful life of smart meter deployments. We're also focusing on the plethora of wired and wireless communications technologies being employed by the smart meter manufacturers. The goal is to provide guidance on the selection of communication standards. One size does not fit all in this case, and not to mandate the use of a particular technology or spectrum. Then there's the matter of supporting plug-in electric vehicles, or PEVs. The interface between the PEVs and the grid needs to support two-way flow of electricity and information and to meet relevant safety codes. At least 7 sets of standards under the auspices of 5 different standards development organizations need to be completed or revised to provide this functionality. These are but a few of the many technical issues that we are addressing with the engagement of the many hundreds of stakeholders in our process. Mr. Chairman, I'd like to conclude with some final thoughts. First and foremost, we will continue to stress the critical dimension of security in our work. We need to design in the necessary safeguards at the very beginning. Second, I believe the approach we are taking to develop standards for the smart grid, a strong public-private partnership forged with active White House and cabinet-level leadership, is the right one. Third, we must aim to develop and use international standards wherever possible to enable U.S. manufacturers to capture global market opportunities. Fourth, NIST is engaging, as Commissioner Kelly has cited, the states as integral partners in the standards effort. And finally, it's essential that we base the smart grid on open standards in order to foster innovation. In conclusion, NIST is proud to have been given such an important role in the smart grid effort. We are committed to achieving the administration's vision of a cleaner, greener, more efficient and effective electric power grid that creates jobs and reduces our dependence on others to meet our energy needs. Thank you for this opportunity, and I would be happy to answer any questions.
Leave it to NIST to hit it within 1 second of the time. I'm sure you're proud of that, and so we're appreciative. Well done, Dr. Arnold. Mr. Martini.
Thank you, Mr. Chairman, and distinguished members of the subcommittee for the opportunity to be here today. Southern California Edison is one of the nation's largest utilities, serving a population of nearly 14 million people in a 50,000 square mile service territory. As a subsidiary of Edison International, Southern California Edison is uniquely qualified to share our experience, progress, and vision in the development of a smarter electricity grid. Edison purchases more renewable energy than any utility in the country, including 65% of the nation's solar power. We pioneered demand response programs and helped our customers conserve more energy than any other utility. We are a leader in the implementation of advanced transmission and distribution technologies, including one of the largest smart meter programs in the country. And 20 years ago, we launched an electric transportation program that includes our Electric Vehicle Technology Center, opened in 1993, allowing us to be a critical player in the development not only of the electric vehicle, but also of improved battery storage technologies. As members of this committee are well aware, the current stakes for addressing climate change energy independence, and infrastructure security could not be higher. And our nation's climate and energy goals simply cannot be met by our aging grid. We need a smarter, more robust electricity infrastructure if we as a country are to rely on greater amounts of intermittent renewable energy, use electricity as a fuel for vehicles, empower our customers to manage their monthly energy bills, and ensure the continued reliability and vitality of our nation's energy economy. In California, we are on a critical path, as we also have a number of ambitious climate and energy policy goals that will require many aspects of our smart grid vision to be operational by the year 2020. Southern California Edison, the limitations associated with our aging grid, and began implementing components of a smarter grid over the past decade to improve our ability to anticipate and prevent outages and empower our customers to make smarter consumption decisions in the best interests of our environment and their bottom line. 3 examples illustrate the breadth of these investments. Edison pioneered synchrophaser technology that allows operators and engineers the ability to monitor the grid at critical points every 1/30th of a second, which significantly reduces the likelihood of widespread outages or a system collapse such as the 2003 Northeast blackout. Edison also has one of the largest deployments of substation and distribution automation technologies in the industry, including an advanced distribution circuit called Avanti, co-funded by the Department of Energy. After the California energy crisis, Edison deployed smart meters to all of its largest commercial and industrial customers that consume in total about 60% of the energy delivered on our grid. Over the next 4 years, Edison is making an additional capital investment of $1.5 billion in smart grid infrastructure that's already been approved by the California Public Utilities Commission. This year, Edison's new smart meter program will begin rolling out to our 5 million small commercial and residential customers. We are also expanding our synchrophaser technology to all of Edison's bulk transmission system, which will be the largest deployment in the United States. As we look forward, Edison believes the deployment and development of a smart grid is a journey that will evolve over the next decade or more and will require significantly more R&D and capital investment to achieve our goals. It will require new technology, open standards, and more robust security. We are actively collaborating with research institutes, universities, product manufacturers, aerospace and defense, and information technology firms to identify opportunities to develop game-changing energy technologies such as energy storage, high-temperature superconducting equipment, as well as adapting telecommunications, cybersecurity, and data management technologies. Edison believes that advancing the smart grid interoperability and security through standards adoption fosters innovation and accelerates robust, secure, and reliable technology developments. We have been active for the past 5 years in several DOE-sponsored efforts, including the GridWise Architecture Council, and have been increasingly active with Dr. Arnold in the National Institute of Standards and Technology efforts to identify and recommend standards for the smart grid. As the smart grid technology is deployed, we believe consumer adoption of new pricing, energy conservation, and demand response programs will be one of the largest behavioral change management initiatives undertaken in public policy. However, the time appears right for introducing change. Edison's research indicates consumers are more clearly recognize that the smart use of energy will save them money and help make a positive difference for the environment. In conclusion, Edison is making significant investments in both capital infrastructure and R&D to accelerate our country's transition to a cleaner, smarter energy future. We look forward to continue to work with members of this committee, Congress, and the administration to make our vision a reality in the best interests of our customers, our environment, and our economy. Thank you.
Thanks, Mr. Martini. Mr. Ross.
Good morning, Mr. Chairman, Ranking Member Inglis, and distinguished members of the subcommittee. Thank you for the opportunity to testify today. I'm Executive Vice President at GridPoint, a leading smart grid software company. We've developed an online energy management solution that enables customers to obtain near real-time information on their energy use and empowers them to make informed decisions about their energy consumption. Our solutions also help utilities better balance supply and demand across a wide range of areas, including electric vehicle charging, storage, integration of renewable energy, and demand response in an economical, efficient, and environmentally beneficial manner. I have 3 points I'd like to leave with you today. First, while the infrastructure of smart meters and advanced communications is important in modernizing the nation's grid, to realize the benefits of increased efficiency, reliability, security, We also need software that allows utilities to better control and optimize load. Second, we need to realign the regulatory and economic policies and incentives guiding investor-owned utilities such that those utilities are motivated to invest in smart grid technologies. Third, we must provide consumers with greater information on their energy use if we expect them to be able to reduce their consumption and their energy costs. The term smart grid refers to energy delivery and distribution using two-way communications and digital technology to enhance the grid with sensing, communications, analysis, feedback, and control technologies in order to improve efficiency, increase reliability, ensure security, and reduce environmental impacts. The Energy Independence and Security Act of 2007 and the American Reinvestment and Recovery Act provide for regional demonstration projects to develop advanced techniques for measuring peak load reductions and energy efficiency savings from smart metering, demand response, distributed generation, and storage systems, and to validate new business models and best practices for implementing advanced smart grid technologies that can be replicated throughout the country. These goals encourage the testing of new technologies. While smart grid will benefit from the investments in smart meters and advanced communications, these investments alone will not realize the true promise of the smart grid. Smart meters and advanced communications cannot by themselves manage peak demand, integrate renewable energy, manage electric vehicle charging and storage, or provide customers with information they can use to manage their energy consumption, all of which can help the electric grid operate more efficiently and reliably. The electric grid needs software and applications to work in conjunction with meters and communications to realize these benefits. Xcel Energy's Smart Grid City is the U.S. first full-scale pilot project designed to test smart grid technologies and the new business models they enable. Since 2008, Xcel Energy and its partners have developed a website portal for customers to better manage their energy use, launched the nation's first test of plug-in hybrid electric cars with vehicle-to-grid capability, turned the chancellor's residence at the University of Colorado into the nation's first fully integrated smart house with solar, backup power, electric vehicle charging, and consumer controls, installed nearly 15,000 smart meters, and implemented a wind-to-battery program to create a more predictable, reliable source of energy. The City of Austin, Texas also announced late last year a new smart grid deployment called the Pecan Street Project that would create a virtual 300-megawatt clean power plant through a combination of efficiency and clean power. These types of efforts would likely increase as funding under the Recovery Act is awarded. There is real value in these types of demonstration projects because they provide a test bed for new and innovative smart grid technologies. Only through testing new technologies can we determine what works in order to spur innovation. Studies have shown that when consumers have more information about their energy use, they typically reduce their consumption by 10 to 20%. Near real-time information on energy use through a portal or an in-home display will empower consumers to control their energy consumption. The portal or in-home display provides customers with energy savings tips and a comparison of their use against earlier periods, among other benefits, which will help them lower their energy consumption. In conclusion, we have an historic opportunity to transform and modernize our nation's electric grid. To do so, we need to look beyond smart meters and communications and invest in the applications that reside on top of this infrastructure to make the smart grid more efficient, reliable, and secure. We must create the regulatory and economic structures that incentivize utilities to make smart grid investments, and we need to provide consumers with information about their own energy use to empower them to control their energy consumption. Thank you for this opportunity to testify here today. I'm happy to answer any questions you may have.
Thank you, Mr. Ross. Before moving on, are you any connection to the Ross of the Ross Power Station fame in the Pacific Northwest?
No, not that I'm aware of.
Ross is a great name in Northwest Energy, so there may be some connection there. Mr. Stoessl.
Good morning, Mr. Chairman and members of the committee. On behalf of the National Electrical Manufacturers Association, I'm Mike Stoessl, Group President of Cooper Power Systems. I've been asked to appear here today to help describe some of the challenges our industry faces in actually making the grid smart. Now, Cooper Power Systems has been providing equipment and solutions to the electric utility industry literally since the days of Thomas Edison. We provide transformers and components needed to connect and restore energy, switchgear and automation technology needed to make the electric grid reliable and efficient, as well as AMI and demand response capabilities that help manage the grid's overall load. Our solutions cover the range of smart grid intelligence. Now, all smart solutions have in common the ability to sense activity on a grid, communicate that information back to some sort of decision support application, send a decision back to the grid, and actually make some change. So as an example, we brought a picture here of a sensor that can help determine when the grid is becoming more or less efficient. If air conditioning comes on in the middle of the day, the grid can actually start wasting energy as it responds to that increase in load. So the sensor you see in the upper right, working with the capacitor bank controller that you see in the middle on the left, can determine that inefficiencies are occurring. Equipped with radio technology or some other form of communication, it will send a signal back to the utility, alerting them to the situation. They, in turn, can then choose to take that capacitor bank, which is in the lower middle of the screen, and turn it on or off using the cap bank switch. This is just one example of a smart application and the sort of things that have to be installed in the field to make it work. Now, one of the big challenges we face with building out the smart grid is the integration of legacy equipment that already exists. Many pieces of apparatus installed on the grid do not provide or support any external interface or have custom communication protocols. So, for example, this recloser that is pictured here provides overcurrent protection to our overhead lines. If there is a fault, for instance, a branch falls and shorts out a power line, the recloser will open, isolate the circuit, and basically try to restore power. Many of these devices do not support two-way communications. So while they're an effective isolated solution, they cannot be truly part of a smart grid without being replaced or being retrofitted. The key to doing these kind of upgrades will be an economic cost benefit to the utility, or it's going to be government incentives based on the value, more intangible value, of a truly more reliable grid. With more than 500,000 of just these type of reclosers out in service today, retrofits of product like this will be an important part of making the grid smart. Another challenge we face in building out the smart grid is the range of communication options that are already available. In the past 3 years, we've seen an increasing availability of cost-effective two-way communication technology. Cellular, Wi-Fi, WiMAX, Mesh RF, line-of-sight RF are a few of these technologies. Now, these cost-effective two-way communications have become an enabler of adding intelligence to the grid, but they also present a host of challenges. So, as an example, the fault circuit indicator, shown here in the upper left, is a great example of a successful product making the transition from being a dumb, isolated solution to a smart, integrated solution. The original form of a fault circuit indicator had no communication capabilities. It simply displays a local orange visual indication when a fault has occurred on the line. And prior to communications capabilities, the utility would literally dispatch their line crew who would drive the lines looking up, trying to find the orange indicator. When they found it, they know where the fault was and they could begin repair. When you actually can communicate with the utility can now know that a fault has occurred, dispatch linemen directly to the source of the fault, which reduces fuel consumption, reduces CO2 emissions, and also potentially can reduce the time of an outage from hours into minutes. That's just one example of what the smart grid can do. However, what's pictured directly below the fault circuit indicator are the range of hardware options that we have to add into the device in order to communicate. Even though there are standards, if we want to communicate over the AT&T cell network, there's a different card required versus communicating through a Mesh RF network versus a line-of-sight network versus the Verizon cell network. Each different choice necessitates a new card. Each card then requires that we integrate it into our package, so it has to fit into the device itself, validate it with a variety of standards, certify it with the communications provider, and then write software, which we grab some screenshots and put at the bottom, to actually interface it with our software as well as the software that the utilities themselves use and have deployed over past decades. So in conclusion, Cooper Power Systems believes Congress, NIST, and the DOE should continue to drive smart grid standards. We also commend the DOE in their preparation for evaluating grant applications for the $4.5 billion stimulus for smart grid investments. We believe the swift and judicious release of these funds will help stimulate the economy and support the process of converting the legacy grid into a smart grid. We would also encourage Congress to consider favorable incentives to utilities and vendors for replacement or upgrades to existing legacy equipment. Thank you for the opportunity to appear before you this morning, and I'm prepared to answer any questions you may have.
Thank our witnesses for a very interesting and informative testimony. I'll recognize myself for 5 minutes for questions. Give us a sense of the glide path of when we begin to see these technologies becoming more adopted. You know, the temptation is to say, when will this be ready? I know it's going to be a gradual transition, but give us a kind of a sense, some metrics that give us a sense of what will be established by what time. And I know that's dependent also on incentives and markets, et cetera, but give us some thoughts about that. Mr. Martini, you might be in maybe one of the best places to.
Sure. Well, I think certainly across the country we're seeing, and in California in particular, the adoption of smart meter technology as a foundational element, as was discussed. Certainly as we see over the next, in our case in California, over the next 3.5 years, all 3 investor-owned utilities will have smart meter deployed for all their customers, building on what we've done already for our largest commercial industrial customers. At the same time, there's a lot of push, and we're certainly at the forefront, but others looking at opportunities as part of the ERA funds for synchrophaser technology. It's very cost effective. So we see that over the next couple of years, that being deployed on the transmission systems. And that has 2 benefits, not only the one that I mentioned in terms of helping to reduce or improve, I should say, the reliability and reduce the exposure to these large blackouts. It also has the benefit of allowing us to be able to understand how large amounts of wind energy can be integrated into the grid because of the very dynamic nature of wind energy. So that's one of the things that we look at in California with a strong reliance on renewable energy in our system. We're anticipating over the next 5 years or so as much as 4,500 megawatts of new wind energy coming on, and so we're looking at that. As we look at these other distribution automation technologies, while we've deployed and many others in the country have deployed quite a bit of distributed automation, what we've had in the last 10 years needs to be taken further. I think it was mentioned in the other testimonies, and I think at the outset in the opening comments, that when we start to look at two-way power flow on the distribution system, many of the relay protection schemes, how we think about and design these distribution systems need to be taken to another level. So part of what we're looking at with this Avanti circuit, but also other demonstration projects, is how do we accommodate two-way power flow on the distribution system that for the last 100+ years has been designed as a one-way power flow from central plant down to the customer.
Excellent summary. What if I'm an average citizen and you say the word smart meter, you're installing a smart meter, what's the difference between the dumb meter I have outside and the smart meter?
Well, the dumb meter hasn't really changed in 50 years. Actually, in exact form factor, it's been pretty much the last 50 years, and really in basic form type in 100+ years. So it's an electromechanical device. It just is it has magnets and it spins on a disc. I think most folks have taken a look at one of those. It's extremely difficult to read because of the way the clocks, in terms of the numbers, are there. So it's very difficult for folks to understand, the average consumer. What the digital meter will do, first and foremost, it is digital. It's two-way communicating. Not only, I think, pretty widely adopted these days, has two forms of communication included in the meter. One, two-way communication methodology back to the utility to be able to do remote metering.
Real time.
Real time. Well, near real time. So we can get the information and we can collect it on hourly or up to 15-minute increments, and then we usually download it once a day or a couple times a day. But we can get real-time reads off the meter as needed. The other communication goes into the home. So there's many of us are looking at wireless technology, Zigbee in particular as one that we're looking at, that allows us to bridge to the many of the devices that Mr. Ross talked about in terms of being able to allow energy management systems in the home to get the read right off the meter every 10 seconds, really real-time information, and take advantage of that. So these sorts of things and more processing and memory capability in the meter are really what distinguish it and features like remote service switches that allows us to remotely turn on the power when somebody moves in. In our case, we have over 20% of our customers move every year. That's over about 1.5 million customers moving.
Thank you. I'm not going to have time to ask a couple other questions I want, but I'll just put those out if someone could be kind enough to share down the road with us. If we get a second round of questions, we'll get to it. I'm interested in the extent to which the energy bill that we recently passed out of the House, a number of folks mentioned incentives as key to adopting or not adopting some of these technologies. How the system of allowances and credits, et cetera, particularly in the cap and trade system, would relate to incentives or disincentives possibly for adoption of this. The other thing is, Dr. Arnold, you know, when we travel the world, we're used to now carrying these little plug adapters. And I'm interested in, you mentioned global standards. I'm interested separately in how we're coordinating with the rest of the world smart grid technology, and so that, you know, we don't create yet another layer of incompatibilities for international travel and international trade and consumption of international goods. With that, I recognize Mr. Inglis for 5 minutes.
Thank you, Mr. Chairman. Mr. Ross was talking earlier about the feedback loop of customers figuring out how much power they're using. The first house that my wife and I bought was heated with electric baseboard resistance heaters. And so the first time it turned cold, I went outside and watched the meter, and I called out to her to turn them on. I thought the thing was going to come busting through the glass and become a dangerous projectile going through the neighborhood. It was going so fast. That was the beginning of the feedback loop, but 30 days later when we got the bill was when the real feedback came about, gee, Mani, do we have to change this technology? So we changed pretty rapidly, because even in warmer South Carolina, it's not that cold, you know, but wow, was it expensive. So I can see the value of a quick feedback loop to change behavior, because you realize, oh my gosh, this is costing us a fortune to heat this house. And Mr. Ross, Dr. Arnold is working on standards. You're in a rapidly evolving area. Software moves rapidly. Is it time for standards? Are you ready for standards, or are you hoping for more development before he gets his standards in place? Or do his standards help you implement your technology?
We've been very supportive of the NIST standards efforts, and really would like to commend Dr. Arnold and all the work that they've done there. You know, they're dealing with a huge area and have set forth a plan in multiple phases that really is moving with good deliberate speed while taking into account all the complexities of the issues they're needing to deal with. From our standpoint, and I think most people in industry are supporting open standards. It would be helpful to have the standards in place, obviously, as quickly as possible, but you really need to balance that with, you know, getting it right and making sure there's enough time to investigate and work through all the issues.
Is there a way to keep those flexible? I mean, because it seems to me in an area of rapidly evolving technology, which I hope is what we're dealing with, particularly in the software, to keep those standards flexible. Maybe a question for Mr. Ross and Dr. Arnold is.
I can just comment, and then Dr. Arnold would have a lot more to say. I think there is. I mean, I think the intent is not to pick winners or losers or very specific technologies, but to be able to pick the types of technologies broadly that will at least allow for interoperability and connectivity, which is a hallmark of the smart grid. But I'll let Dr. Arnold talk about that.
Thank you. Well, we have to be careful not to over-specify things, because we do need to facilitate innovation, which will benefit the consumer. There are certain aspects in the standards that everyone agrees have to be common, like you have to have some common understanding of what data are you going to have, how is it going to be represented, and these are things that people can agree on. We can allow a lot of flexibility in terms of things where, you know, people can innovate and get you know, benefits to consumers, and they're built on this foundation of, you know, sort of the key fundamental standards, you know, data models and so forth. So we're proceeding to address this in, I think, a thoughtful fashion.
Yeah. What's the holdup with net metering? I hear, you know, a lot of people have trouble with theoretically. I think EPAC 05, right, really requires power companies to allow us to do that, right? But then there are all kinds of questions about the ability, the actual ability to sell your power back to the grid? What's the holdup? Is it technological, or is it a business issue, and we really don't want to move quickly if you're in the power business?
In terms of net metering, there's actually two dimensions. One is net metering, where you're netting out how much energy is being used by the home, and then there's the metering that you'd have just a separate meter to be able to then get paid for the energy being produced at the home. The current meters that we're deploying, the electronic meters, have capability to do net metering. They also have the ability, if we put a discrete measurement device on say, a solar panel, to be able to measure that, and we're looking at this also for the vehicle. I think Dr. Arnold talked about this, as well as when we look at energy storage, potentially in the home or at the business, how we'd be able to measure that as well in terms of its contribution to the grid, not only for energy, but also what other services it might provide in terms of grid stability. So we are looking at that. It's really, it's not a technology issue. I think we're looking at what the new form factors need to be able to do that, and then there are standards, both in terms of interconnection standards that might be required, as well as some technology standards to deal with these different form factors, because in most cases these meters would have protection on them, unlike the meter on the side of the house that doesn't, and so there's different safety considerations. Yeah. Lower ones, actually.
Mr. Lujan.
Thank you very much, Mr. Chairman. And I'd like to start off with where Chairman and Ranking Member's questions have gone as well, with talking about some of the open standards, not picking winners or losers, but the importance of interoperability. And as we look to see some of the technologies that we depend on every day, our cell phones, as an example, which are developed in open platforms, but where we in the U.S. have not kept up with some of the technological advances that have occurred in other nations. And when you talk about an open platform, but some of the restrictions that are placed on consumers as a result of carving out niches within this industry, can you talk about the importance of interoperability and some of the minimum performance standards that should be included, so that way we're able to maximize efficiency, cost effectiveness when we're looking at consumers' implementation and the integration with utilities as well?
Well, I think we have to be careful not to fall into the trap of thinking that one size fits all, because the smart grid has to accommodate a nationwide infrastructure. Environments in rural contexts are very different than urban areas. So there have to be a range of technologies that utilities can employ, and we don't want to impede innovation. So the challenge in this effort is to identify the critical interfaces in which there needs to be a standard, and the nature of the standard has to be right as well. One example that I'll give you is that a standard for communicating dynamic pricing information across the grid is going to be a very fundamental standard for the smart grid. But we have 53 jurisdictions in the United States that set tariffs and rates, and they're not all the same. So we can't have one pricing model. So the type of standard that we need there is a language to describe pricing models, and this is quite doable. So it's a combination of recognizing which are the key interfaces and applying the right type of technology to create the right type of standard.
Very good. Anyone else comment on that?
From the regulatory perspective, both the federal and state regulators have recognized the importance of interoperability at some level, and in the absence of interoperability, of open architecture. And the state commissions adopted a resolution at their meeting, their national meeting yesterday, that pledges the state commissions to ensure that any smart grid technology that is sought to be deployed on their systems, that they'll require that the architecture be open. And in FERC's policy statement for cost recovery, we've made the same statement.
Thank you. And I'd also like to second the thoughts of Mr. Inglis as well, as it pertains to net metering. As we're looking to smart meters and the importance of making that inclusion, as we're making this critical investment now to prepare homes and the investment that's been made with smart meters for those individuals that would like to get involved in that type of an environment, I think is critical, and would hope that that would be some type of a parameter that would be established. And lastly, Commissioner Cowley, just to applaud your efforts with what you have done in the collaborative effort between FERC and NARUC to bring those two entities together to talk about the regulatory environment that exists, the framework that has to be adopted, and how the two can truly adopt best practices throughout the United States to help carry this out. And if you can just touch upon any of the practices that you've already identified or the progress can be made, and how we as a Congress can provide the support that we need, whether it's for FERC, DOE, NIST, with NARUC, to help you do what it is that we need to do, recognizing that all of your testimony supports the robust investment that's been made in smart grid applications, recognizing the investments that can be made and the progress that can be made over the next 5, 10, and 15 years.
Well, thank you, Congressman. It has been a very fruitful effort, this collaboration between the states and the federal government. In addition to adopting a policy that interoperability has to be met by all smart grid investment, cybersecurity has also been a concern of state regulators as well as federal. And we've pledged ourselves to demand that any smart grid technology that comes before us for approval for deployment to the grid will have to be shown to be cyber secure. You already have helped us with the stimulus funds, and in the ARRA, you created a clearinghouse of information, which the Department of Energy is working to establish right now. And we see both of these as very helpful for the encouragement of deployment of the smart grid. With the stimulus funds, we're anxious to see them spent on demonstration projects that actually demonstrate a range of technologies from the transmission end down to the distribution end, because some of these technologies are not known. So if we can have a demonstration project and get the information from that project that shows that this technology performs, that it actually provides benefits that we can quantify and report on, and that it has been accepted by consumers, this is a wonderful way to kickstart the deployment of smart grid technology and advance it. So thanks for your legislative efforts.
Thank you, and thank you, Madam Chair. I see my time has expired, and would invite any of the other panelists to submit a response to that question, if you so choose, in writing for the record. Thank you very much. Thank you, Madam Chair.
Thank you, Mr. Lujan. The Chair will recognize Mr. Bartlett.
Thank you very much. Just about a week before the G8 ratified the framework agreement that ended the Kosovo conflict, I was sitting in a hotel room in Vienna, Austria, with 3 members of the Russian Duma and the personal representative, Slobodan Milosevic. One of those Russians was Vladimir Lukin, who was ambassador here and at that time the chair of their, what would be our Foreign Affairs Committee. He was very angry, spent 2 days with his arms crossed looking at the ceiling, and finally he said, if we really wanted to hurt you, with no fear of retaliation, we'd launch an SLBM, we'd detonate a nuclear weapon high above your country, and shut down your power grid and your communications for 6 months or so. The third-ranking communist was there, Alexander Shabanov, and he smiled and said, and if one weapon wouldn't do it, we have some spares, like about 10,000, I think. What was he talking about? I won't ask Ms. Hoffman because I know that she knows what he was talking about. But let's start with Ms. Kelly, because this really is relevant to this hearing and what you all are doing. What was he talking about?
Well, Congressman, he was talking about electromagnetic pulse, and he was thinking about using it as a threat to the stability of the United States. And it is a concern. It's a physical threat as opposed to a cyber threat, but nevertheless a very real threat.
Mr. Arnold.
Well, this is indeed a very serious concern that we must address in the context of the smart grid. And although it is a physical threat, it does have cyber implications, because the greatest damage with that threat is to the control systems, which are based on electronics. We consider that threat to be within the scope of the cybersecurity task group within the NIST standards program. We have a number of EMC experts who participate in that group, and NIST has expertise as well. I would just like to say that I'm aware that some of the manufacturers are at least sensitive to the issue, and several of the manufacturers on our working groups have informed us of research they're doing on component technologies that are more EM immune than conventional circuits. There are existing approaches with layered magnetic shielding to create EMP-resistant designs. And there are applicable standards. IEC Subcommittee 77C has had work underway for some time and has produced a series of standards. The real challenge in this, and I'm reminded of this by the report of the Commission to assess the threat to the United States on EMP attack, in which it says, it's not practical to try to protect the entire electrical power system or even all high-value components from damage. So I think the key to this is identifying which are the critical assets that need to be protected and to apply the relevant design standards to ensure their protection.
Yeah, the smarter we make the grid, the more vulnerable we are. And unless you are incorporating EMP protection, you're simply making it worse rather than better as far as security is concerned. Mr. Martini.
Yes, in addition to what Dr. Arnold described, the other potential threat, physical threat, has to do with the long cycle currents that are induced under one of the three different scenarios. There are three different pulse sort of effects that are result as from EMP. The second looks and acts like lightning on the system, and the current grid use of lightning arresters and protection devices will mitigate that. The third, though, is the one that has the most potential physical damage for things like transformers and other large equipment that we have on our bulk transmission system and also on our distribution and sub-transmission systems. There are ways to approach this. This is also similar to a phenomenon, this third, to solar flares, which is fairly well understood. There's been a number of scenarios over the last 20, 30 years, one at Hydro-Quebec in the 80s, and some of the technologies that they've deployed. Again, I think to Dr. Arnold's point, what we need to look at is sort of a risk assessment and looking at what we think the key vulnerabilities. In the case of the physical infrastructure, it's long lead items like transformers. So if a transformer was to fail, getting a new replacement transformer for a 500,000 volt transformer is very long.
Well, what's very long?
Could be 2 to 3 years. If we had a very wide scale, usually if we have one fail, we can, there's a sharing arrangement usually with other utilities and manufacturers so that we can get something quick, as in the case of an earthquake. But when we talk about widespread, damage, then that obviously we'd exhaust those standbys. So looking at ways to isolate those transformers or dampen those currents that may get induced into the system is something we can look at. And on our 500 kV system, for example, in the West, and particularly in California, we have series capacitors that to help actually shorten the lines, which is one of the things you can do to mitigate the exposure from EMP.
My time is up. Let's come back to this in a second round because it really needs more exploration, because if we don't adequately respond to this, it could really, if we had that event, end life as we know it in this country. So let's come back to that in the second round. Thank you, Mr.
Thank you, Dr. Bartlett. Ms. Giffords.
Thank you, Mr. Chairman, and thank you for the panelists for being here today. I come from southern Arizona, and it's a state that's abundant in solar energy and incredible potential in this natural resource. As you all know, smart grid technologies provide a real relevance to the goal of making our state and the country more dependent on renewable energy, and particularly solar, because of the storage capacity issues that deal with the sun setting at night and clouds coming overhead. So I want to talk a little bit about what happens under the traditional rate-making process. I mean, there are very few ways currently that utilities can monetize the benefits of of storage. Since storage technologies do not fall into any of the traditional asset classes like generation or transmission or distribution, it's really a struggle for the utilities to use storage as part of their rate base. So my question is, what can FERC do to encourage the use of energy storage in light of these circumstances? And should FERC institute a separate class or asset class for storage, since it provides benefits for the generation and the transmission and distribution of energy?
Thank you, Congresswoman. You're absolutely right. Storage is not a traditional resource on the system. The traditional resources are generation, transmission, and distribution, and that's how rates have been set. Storage can potentially act as either one of them or all three of them, and that's where the difficulty comes in. If it is acting as a generator, for example, pump storage, a traditional storage facility, then it receives revenues as a generator. Some of the issues that get more difficult come if the deployer of the asset wants to capture multiple revenue streams. I know that there was a proposal by AEP that was at the distribution level in Texas that would have been a distribution asset, and the Texas Commission did approve that in distribution rates, and I believe also allowed them to recover revenues as a generator at the same time. One thing that FERC has done to facilitate storage is to allow, is in our organized markets. We have 7 organized markets in the United States, and we've allowed storage to qualify. We've changed the rules so that storage can qualify as a demand response provider, and we have lithium-ion batteries in particular that are, although they're expensive, they can provide ancillary services because those ancillary services are costly. So we are working to change market rules to allow storage to sell power into the market. We also have a Office of Policy and Innovation, and 2 months ago they began an effort internally to decide whether this is something that we should develop a comprehensive policy on, or whether it's something that we should decide on a case-by-case basis. Because you're absolutely right, storage can act as a number of different kind of entities within the system, and the question is whether or not they can recover as a transmission asset and a generation asset has a lot of implications for the market and the competitiveness of the market and cost recovery. But it's something that we're undertaking to look at to see whether we should come up with some sort of comprehensive policy.
Thank you, Ms. Kelly. Would anyone else like to comment? Ms. Hoffman?
I just would like to comment that the best thing we can do for the industry is to develop a clear definition of those services and what can be covered under what cost structure, so that the industry knows how to move forward, where they can get cost recovery, so it's completely transparent and consistent.
Great.
I would just like to say we agree with your view. Storage is a very attractive solution for many utilities. The price points are coming down now with some of the advantages gained through the development of batteries for electric vehicles, and I think those price points are now approaching new generation, and I think more clarity would be beneficial for the industry. Because today where we're at, there are some utilities that have deployed storage solutions, grid-scale storage solutions, but it's tended to be basically on a pilot basis and not more wide-scale.
Mr. Chairman, I just in closing, this seems to me a real key part of how we're going to figure out transitioning to renewable energy. And I'm glad that you're holding this hearing today, and I look forward to working with all of you to make sure that we can actually get these changes in place so that we can really move forward and transform our economy and our energy usage. Thanks.
An excellent point, as always, Ms. Givers. Maybe we want to pursue specifically a hearing on the issue of storage in some more detail.
That'd be a great idea.
Dr. Ehlers.
Thank you, Mr. Chairman. I don't know about you, but I'm having fun. It's not every day that we get a panel on which every member knows what they're talking about. So I've learned a lot. Just one quick comment on the EMP. When I look at that issue, I just think this is so far beyond what anyone should do that it almost is in the category of mutually assured destruction as being the only defense against it. We can protect some things, but good grief, given all the processors around and everyone, if every car stops because of EMP, you have total gridlock, the nation doesn't function. So it's something we'd rather not think about, but I really think it's very, very difficult to address the whole issue. On the smart grid, it seems to me a smart grid requires smart people too. And I think the comments about digital meters, I think we would do everyone in this country a great favor if every major energy consuming appliance had a digital display on the appliance showing how much energy it was using at that moment. This would apply to stoves, dryers, washers, dishwashers, the major appliances, perhaps even the furnaces and air conditioners, although you wouldn't want the display on the machine per se, but somewhere in the house. People have to become much more conscious about their energy uses if we're really going to be serious about conserving energy. And so I don't know, Dr. Arnold, whether you want to put this as one of the standards, but I certainly wouldn't mind seeing a recommendation in there that this is something we should move towards, and perhaps it requires legislation at some point. When the public, I think the public will make intelligent decisions if they know the facts, and we have to make sure that we let them know the facts in every way possible. Question I have is, what is the primary purpose of the smart grid? It seems to me its origin was in the blackouts and concern about that. But what you're talking about today and discussing is far beyond just dealing with blackouts. And I don't have much time left, but if you can each give just a short response of what really are we trying to accomplish with a smart grid? What is our purpose? What is our goal? We'll start, well, let's reverse the order. Ms. Hoffman, you get nabbed every time. Mr. Stoessl, and just go down. And I'm looking for short answers, not long ones.
I think, unfortunately, smart grid has become something that is ubiquitous. Everybody takes anything going on in the grid and calls it smart grid application. But from our perspective, improving reliability is a key part of it. Improving conservation of resources and reducing waste is a key part of it. And providing signals to both consumers as well as the utilities on how to reduce waste, reduce usage, is also a key part of it.
Thank you. Mr. Ross.
Yeah, I would agree with a lot of that. I think it's to create efficiencies. I think it's to improve reliability. We should have as a goal to increase security, and I think there's a lot of work being done on that. I think those are the main prongs.
Mr. DiMartini.
I'd say there's three things. One is that if we look at renewable energy integration, large amounts of wind and distributed solar energy, we need a different set of technologies to be able to integrate that in a reliable, safe manner. The other is the efficiencies that were talked about. Two elements. One is there are technologies, superconducting technologies, that can make our grid, the inherent grid, more efficient, which means less energy wasted through losses on the system. And then obviously engaging our customers in the process that you described in terms of using more efficient energy. So I would say those, and then overall reliability of the grid in terms of providing better service for our customers.
Dr. Arnold?
I think of it as reducing energy usage, consumers to manage their use of energy, increasing reliability, and benefiting the environment.
Ms. Kelly?
Congressman, I think of it as doing the same thing that the dumb grid does, which is send electricity, only doing it better, more efficiently and more reliably, and then increasing our ability to do things with the grid that it's never done before, like sending electricity two ways, allowing for net metering, and allowing for dynamic price signals and automated demand response, things that we can't do with the dumb grid today.
And Ms. Hoffman?
I will summarize it as sensing, measurement, information, decision-making, and automation, such that we have a greater, as you eloquently stated, an educated consumer and a more sophisticated industry.
Thank you very much. Just to summarize, most of you mentioned the issue of efficiency, which I think is a huge issue that we have to deal with internationally, not just in this country. And I appreciate your comments. They're right on target. Thank you, Mr. Chairman.
Thank you, Mr. Chairman. Thank you for holding this hearing today. It's very important that we talk a lot about alternative energy and what we're doing, but certainly this is another critical part of the equation that oftentimes gets overlooked. I want to start out by asking about this. I read recently that the National Association of Regulatory Utility Commissioners reported that the most effective place for initial investment in the smart grid for smart grid improvements is on the electric grid itself, where energy and cost savings are immediate and don't rely upon changes in customer behavior or for customers to purchase and install in-home energy saving devices. So I was wondering what the panelists think about the Commissioner's assessment. Do you think that that is the best way to start building the nation's smart grids? And maybe start with Ms. Hoffman.
I actually think we need to drive innovation and smart grid technologies on all three levels, at the transmission level with the phaser measurement units, at the distribution level through substation automation, and at the customer level. The safest route from a regulatory commissioner's perspective is something that's dealing directly within the industry or within the utility industry itself. The most competitive and most innovative aspect of the smart grid is on the consumer side for consumer decision making.
Ms. Kelly?
Congressman, I would agree with Ms. Hoffman. The state utility regulators are concerned because the technology that we're talking about putting in is new to them. And so I think that the DOE demonstration projects will be very valuable in demonstrating that the technology does perform, that it does provide benefits, and that it is accepted by the consumers. The technology that they referred to is technology that we understand pretty well and we could put on the transmission system. And I think that's one reason they endorse it, because it's known, it's well known, and we know how much efficiency can be delivered by it. But and so from that perspective, I think that it is important that that kind of technology be deployed. But in parallel, we should be undertaking these demonstration projects to show that other technology can also work well.
Yeah, anyone else have a comment?
I'd add that, yes, thanks. I think that it's important to recognize what, for example, in California, and certainly in Southern California, Edison's case, our peak, system peak, is occurring on less than 60 hours out of the year. During the period from 2002 to 2007, when we were experiencing the dramatic growth in our economy, our average peak demand was growing by about 1,000 megawatts a year. That peak, 30% of that peak, 7,000 megawatts, is air conditioning load. As we look at investing more in capital to try and meet that type of growth, which we anticipate that we'll see again once we come out of this downturn, it's important that we engage our customers in a way that they can see what prices are, what the cost of this energy is going to be, so that we can have this very mutually beneficial relationship, that we can meet their needs, but also that they can recognize what the cost of this is, so we can end up with a much more efficient system. It's just not possible to continue to try and meet that sort of growth.
Yeah, I'd like to just comment on that as well. I agree with what the other panelists have said. I would like to point out that a lot of the work that's been done to date, though, really has been on the grid operations reliability side. So we've done a lot in transmission. We're doing a lot at substations and distribution automation. Where we haven't done a lot so far really is on the demand side and looking at efficiency. And so a lot of those things, hopefully through the smart grid demonstration projects and elsewhere, we'll see new technologies that can be deployed. But those things have done, at best, very small pilots. So a real focus on efficiency and addressing the demand side as well as the supply side, I think, is needed.
Thank you. The little time I have left, I want to ask Ms. Hoffman, is DOE spending any of the stimulus dollars on efficiency improvements on the electric grid itself?
We are through the demonstration program where we will have a complete portfolio of generation as well as smart grid technologies that will hopefully show improvement in the efficiency of the whole system, the system as a whole. For the investment grant program, they're very technology specific actions or proposals that will be submitted to the department, so some of them could, but not all of them probably will.
Thank you. I see my time is up with that. Thank you for your answers, and I'll yield back.
Thanks, Dr. Lipinski. Ms. Biggert.
Thank you, Mr. Chairman. This must be Smart Grid Day. I co-chair a caucus on high-performance buildings, and the title of what we're having today is Connecting Buildings and the Smart Grid. So it's obviously is a topic that's very much in the forefront. I do chair this caucus with Representative Carnahan from Missouri. So if you happen to be down in the basement of Rayburn around 11:30, that's when that starts. If you need some more talk about the smart grid. But I read recently that the National Association of Regulatory Utility Commissioners has reported that the most effective place for initial investment in smart grid improvements are immediate investments in the smart grid improvements is on the electric grid itself, where energy and cost savings are immediate and do not rely upon changes in customer behavior and do not need customers to purchase and install in-home energy savings devices. Do you agree with that assessment as the best way to start building this nation's smart grids? Ms. Hoffman.
Congresswoman, thank you. I believe that we really need investments at the transmission level system as well as at the distribution and at the customer level. The innovation that is occurring on the system is occurring at the customer level as you look at the wealth of technologies, including appliances, with the intelligence in that will provide a great advancement and great education to the industry as well as consumers on their energy consumption.
Thank you.
Congresswoman, that technology that they're discussing there will indeed provide a lot of efficiency and translate into a lot of savings for consumers. However, I don't think we want to lose sight of the fact that adding smart grid technology at the retail level in the home also has the potential to do to accomplish similar types of savings.
Thank you. Anybody else? Mr. Stoessl, you mentioned something in your testimony about
absolutely, and I think that while it's essential that we invest everywhere, I think if you really want immediate gains, the fastest response is going to come from going after management of efficiency on the grid itself, voltage management and reactive power management. That first example that I provided, looking at how you turn capacitor banks on and off or turn voltage regulators on and off when load shifts in, when demand shifts and the load comes up and down. That's something the utility can manage directly without relying on consumers to get queues and individually make a whole host of actions. And so I think there are opportunities for immediate benefits going at that direction while waiting for all the cues that the consumers will need to manage their own consumption, which is going to be very important down the road as well.
Well, you know, we hear a lot about the smart meters and the programs to enable consumers to reduce energy use, usage and shift part of it to particular times of the day. But it seems that that there's more to the smart grid, essentially making the utility systems themselves self-healing, as you've mentioned, Mr. Stoessl, making them more reliable and more efficient and lowering the cost of electric delivery. But if this is so, Ms. Hoffman, how is DOE encouraging the deployment of these types of smart grid systems?
Well, hopefully we will get some wonderful proposals through the American Recovery and Reinvestment Act that demonstrate some of the objectives that the legislation asked us to do in advancing consumer behavior, managing load on the system, as well as we look at supply and demand, increasing the availability of renewable resources. I believe that through the American Recovery and Reinvestment solicitations, both the demonstration as well as the investment grant, we will have taken a major step in the right direction in doing projects as well as documenting the benefits of these projects.
Thank you. I yield back.
Thank you, Ms. Biggert. Mr. Davis.
Mr. Chairman and Ranking Member, thanks for having the hearings today to better inform those of us who will be making decisions on energy issues in the future, whether America can become more energy independent and more economically secure and have greater national security. I look at the issues today that I hear discussed so often from everyone in this room and everyone in the district I represent and throughout the country, and each seems to have a better mousetrap. And I'll explain what I'm saying. The windmills quit moving when the wind quits blowing, and the solar systems quit working at least to 100% efficiency when the sun goes down. We're putting 50% of our energy production is from coal, which belches into the atmosphere carbon emissions that seems to be destroying, and I believe destroying, our planet. About 24 to 25% from nuclear energy. We had no place to send the spent rods. And then some 20% or so would come from natural gas or from fuel oils, and then 1 or 2% from hydro and the wind and the solar. And now we talk about a grid that would transfer all of the energy that we are producing, wherever the source may be, in a more efficient and effective way, to where perhaps we can reduce the amount of generation, which means we reduce the amount of pollution, or more efficiently and more effectively transfer electrical energy that we're producing in certain locations throughout America. It is my understanding today, and I live in the Tennessee Valley area, I represent Kingston, where the spill is located. And so obviously all of us are trying to find some way to, whatever we're producing today, to find a better use of that. So with the grids that we have, my understanding, we transfer now energy being produced from one particular company to another, or from one area, one region to another. How do we redo the grid system to where that it can become more effectively? And if we do, with the costs we're talking about, how much more can we wring out? And how much can we reduce the generation that we have today as a result of that 1%, 2%, 3%, 5%? Would you give me an estimation of how, if we had the perfect grid system based upon your knowledge and study, how much can we save in production?
I don't have an exact number with the savings, but I'll characterize it a little bit differently. If we can reduce the peak on the system, we can show great savings. So if we actually can flatten the loads of customers and flatten the transfer on the transmission system, we will get the greatest value and benefit. There are some numbers out for peak load reduction. I don't remember the exact savings numbers, but I can provide that to you.
When it gets 100 degrees in Tennessee and it's 150% humidity, we all turn our air conditioners on, and we want it to be about 75 degrees. And so that produces a peak. How do we convince that customer? And what you're saying is we need to reduce the amount that we're consuming, so therefore we don't have a peak. How do we do that? I mean, how does the grid system bring about a reduction in peak use for those customers who feel they need that energy?
Well, one of the technologies is you actually can cycle the air conditioners through price signals. They can cycle some sort of incentive program for cycling the air conditioners, and that's been a common program that has been.
And that works because I just put like a 16-seer in my house from propane to electricity, and we just changed all of the light bulbs. But so we're not talking about grid now. We're talking about actually efficiency. And conservation.
And consumers' decision. You can have the air conditioning running, and there might be a price signal, but the consumers may say, okay, well, I'm not going to start my dishwasher at this time. So you look at all the factors that pull together, not just the air conditioner.
Yes, Ms. Kelly.
Thank you, Congressman Davis. The FERC recently completed a study which the Energy Independence and Security Act asked us to do on assessing the national potential for demand response. And in that study, we determined that in a perfect world, we could reduce peak 20% over the next 10 years. Those are the numbers I think that Ms. Hoffman was talking about. Now, that would be a perfect world, but that perfect world would be all consuming entities having a smart meter and having that smart meter send the real-time price signals, dynamic pricing, and having the devices and appliances have smart chips in them that could automatically respond to the price. And but that estimate, 20%, is very significant.
Yes.
It would be 120 gigawatts. Today, we consume on peak about 820 gigawatts, so it would be very significant.
At our home, it has reduced more than 20%, the actual consumption of energy as a result of those two. So we're not necessarily talking about a grid that makes it smarter use. We're talking about customers who will be smarter users of the energy that we produce, and that is a task for us to be. Thank you, and I apologize for running over my time.
Thank you very much, Mr. Chairman. It's been a very educational hearing, and again, I agree with Mr. Ehlers, and all of the panelists have contributed to our knowledge base on this issue, which I consider to be vitally important, because I think that in the future our country will be relying on electricity. Electrifying America even more than it is probably the answer to the pollution problems that we face, the challenges that we face today. I might add that the pollution, those of us who don't believe that global warming is a problem caused by CO2 are very concerned with pollution and very concerned with America's energy independence as well. I'd like to get back to the question that my colleague just brought up about the how much energy we're talking about here. You guesstimated it a 20%. We could actually have, with the smart grid, we'd have a 20% more efficiency in operating. What about today? How much of the electricity that's put into our system is dissipated in some way that wouldn't be dissipated if we were handling it in a smarter way? And I don't know, maybe whoever can answer that. How about the guy from Southern California, Edison? They know all that.
Thank you, Congressman. I don't have the exact number for our system, but it's not unusual to have a system loss from the time it goes from generation down to the customer,
right?
Somewhere in the neighborhood of maybe 7%.
7%.
Yeah.
Okay. And so we are actually producing 7% that never goes into the some electric device in your home and things like that. That's just not used for the benefit that it could be used for.
That's right. That's through the losses in the transmission of the power over the power lines, as well as through the transformers. So in the transformation from one higher voltage to a lower voltage, or stepping up in that transformation. And actually, superconducting materials both applied to the conductors, but we think that there's a lot of potential to apply to the transformers. And that's an area that we're putting a lot of focus on to see if we can't get some of that developed, because that could be pretty easily to replace over the next decade.
So one of the goals of a smart system would be to bring that 7% number down,
right?
Which could pay for itself, actually, when you think about what we're talking about here. And when we talk about smart meters and two-way meters, how would a customer in the future be expect that if he puts solar power panels on his roof, or finds a way of producing electricity with whatever method that would be, would that customer be expected to receive a financial benefit from that other than just the fact that he's not buying it? In other words, putting into the grid would receive some benefit. Is that what the goal is, or is that not the goal?
Yes, Congressman, that's what we mean by two-way flow of power. Indeed.
So what would that be? Would someone be able to receive a payment back or a credit for that would be in the same dollar amount as what it would cost him to take out, he or she?
Congressman, it really depends on the nature of the marketplace that they're selling into. If it's a traditional regulated utility, then it would an offset from the bill. If they're in an organized, we have 7 organized markets within the United States. Doesn't cover all of the United States, but 2/3 of the consuming areas of the United States. If they sold into that organized market, they would get the clearing price of that market, the market price at the time they sold into it.
So they get the market price. So someone,
they could get the market
if
price.
Someone has, like Dr. Bartlett here, has a farm and he produces more electricity because he has got all the solar and the wind going, he'd actually make the same amount of money as Southern California Edison in producing what he's producing. Is that right?
Particularly if he sold it back on peak when the price is higher.
Okay. Well, thank you very much again. This has been very educational. Appreciate your leadership, Mr. Chairman.
Thank you, Mr. Chair. Apologize that I had to leave the hearing to go off to another meeting, but so if I ask a question that's been asked, just tell me. Workforce development as it relates to smart metering and an upgraded grid, has any discussion been had in that regard? Are there things you would advise this committee in terms of the human infrastructure that's required in order to do this in the most effective way, whether it's retraining workforces out there or entering some new? And what potential exists in the future? Are there career developments we should be doing as early as high school, or in the state of New York, we have a BOCES operation that will deal with some of the developments of more trade-related aspects. Are there any comments that any of you would wish to share?
Let me start, Congressman. Thank you for the question. It's a very important question as we look at our aging workforce today. And in the American Recovery and Reinvestment Act, there is $100 million that's set aside for workforce training. The issues surrounding workforce training, as we look at putting more advanced technologies on the system, we will need to retrain workers that traditionally may do line work, may have to also be able to handle solar cells on a pole, on the electric system, as well as we need to have more sophisticated workforce coming into the electric industry as we start advancing power electronics. And as we look at cybersecurity, the information technology is probably not the way current line workers have utilized information technologies. There will be significant advancements with respect to computer use and information technology on the electric system that we need to make sure we advance the workforce in having them up to speed. And I believe that requires education at the high school level and at the starting point with respect to computers, mathematics, and following that all the way through the 2-year colleges.
Mm-hmm. Yes, anyone else? Or?
Southern California Edison agrees, with Ms. Hoffman. We believe this is actually one of the larger issues that when we start to look at a smart grid, as Ms. Hoffman pointed out, there are fairly large challenges with the workforce that we have today. The average age of our workforce is nearing retirement or already retirement eligible.
And that's a pattern across the country, I think, especially in states where they deregged.
Across the industry, so we're not unique in that regard. And one of the things that we've seen is that as over the last 15 years, when construction and growth of the electric industry sort of slowed down after the 80s, the university systems largely dropped their power system certificate programs for the electrical engineering curriculum. So there hasn't been a lot of graduates of electrical engineering programs specializing in power systems development. The other thing that we see is clearly as we move forward, it's not just enough to reinstitute those curriculum, because today a power system engineer also needs to understand computing systems. So we're working with a number of universities to try and reestablish the certificate programs and expand that to include computing systems, computing sciences as part of that. The line worker is a real challenge because most of our line workers and field workers are basically high school graduates, and so they haven't had extensive sciences, or certainly not electronics. And it isn't just the solar cells, although that would be a challenge as well. We're going to have a lot of power electronics out in the system, out on the circuit, as Mr. Stoessl highlighted. So as we have that, our folks need to understand, electronics, which means that there's more education. So this is something we look at both with the labor unions in their development of their apprenticeship programs, community colleges we're reaching out to. This is a very large issue that the industry across the board is trying to
Is the planning element of that all structured enough, or should the feds step in or states step in and make certain that all this is getting accomplished in the most effective way?
I believe most utilities are very well aware of this, and we've been looking at this issue and starting to put in place plans to develop it. Obviously, certain budgets in many of the locations across the U.S. for education are under pressure, and so developing new programs can be quite challenging to be able to move this forward.
Thank you. I made that right on. I had 1 second left, Mr. Chairman. I wanted to point.
Well done, Mr. Tonko.
Following our leader there,
Mr. Olson.
Thank you, Mr. Chairman, for allowing me to participate in this hearing today. Greatly appreciate that. I'd like to follow up on my colleague from New York's questions about workforce development and specifically job creation. In April of 2009, Vice President Biden announced funding the amount of $4 billion through the American Recovery and Reinvestment Act for smart grid initiatives. He did so under the premise of job creation. And that same day, a notice of intent was released by the Department of Energy, which stated that job creation would be a primary criterion for ranking projects receiving funding under the program. However, revised guidance issued on June 26 has eliminated job creation as a primary criterion for funding. The funding opportunity announcement for Smart Grid Initiative grants in the section entitled Frequently Asked Questions, it states that DOA removed the criterion on the extent of jobs creation and will now require applicants, as stipulated within the Recovery Act, to report quarterly on the number of jobs created and retained. And we were told during the debate we had on the floor on the stimulus package that the urgency behind the measure was due to the need for job creation, and yet we've seen, it looks like, that the exact opposite is occurring. And so my question for you, Mrs. Hoffman, why the change in criteria?
The final funding opportunity announcement that came out recognizes that job creation is recognized throughout the solicitation. The major goals of the solicitation as listed, I believe in the introductory section, says job creation is a goal there. The proposers have to write towards those goals in recognizing job creation as part of their proposals, as well as the companies themselves must define the workers they require to implement projects on that solicitation. So we thought that we included job creation in almost every aspect of the technical requirements and the evaluation criteria of the proposal.
Appreciate that answer, but let me read to you from the document that was issued on June 26th. The question is, will DOE use the number of jobs estimated to be created and or retained as a criterion for rating a proposal on funding? And the answer is no. And then they downgrade it and say, although job creation is not included in the technical criteria used to rate proposals, it plays an important role throughout the grant process. And grant recipients, again, are required to submit the numbers of jobs created and retained in their quarterly reports to DOE-recovery.gov. And to me, that's a significant de-emphasis of job creation as part of the Smart Grids initiative. And following up on that, Mrs. Hoffman, if jobs creation, as you say, is still a factor driving the force behind these grants, how many jobs do you foresee will be created using the smart grid initiatives?
We are following the Council of Economics Advisors methodology for jobs creation, and I don't have the number off the top of my head of the numbers that they've quoted as part of their methodology. I know KEMA also has a separate number for jobs creation, which I don't have in front of me at this moment in time.
Appreciate that if you could get it to us. And follow-up for you, Mr. Arnold, as well. In your testimony, you stated that smart grid is a critical piece of this administration's overall goal of fostering and creating millions of jobs in the green economy. And again, how does that statement coincide with this shifting standard that I've been talking about?
Well, I can talk about the role that standards play in that, and one aspect is enabling global market opportunities for U.S. manufacturers. And addressing Chairman Baird's question, we are working very actively with the key international bodies such as the International Electrotechnical Commission, the IEEE, and others as a vehicle for promulgating standards that we're going to use in the U.S. smart grid. We're also engaging directly with other countries that are really following what we're doing. I would say we're in the lead in the world on this, so that we can collaborate in the creation of international standards that will provide those global market opportunities for U.S. manufacturers.
Thank you very much. I see my time is ending. I just want to encourage you all not to de-emphasize the jobs creation part of this. That is critical. If this is going to go forward, we need to create jobs, and it appears that it's being de-emphasized. And Mr. Chairman, I yield back my time.
Thank the gentleman. I'm told by staff we may have votes in about 10 or 15 minutes. I know, Dr. Bartlett, you had a follow-up. I'd like a brief follow-up. Are there other members who anticipate?
If we have time.
Okay, if we have time. So we'll go ahead and start. I'll try to shorten my time a little bit as well and ask colleagues to do the same. We had a markup in this committee this week earlier on a proposal to put social behavioral science program within DOE's work. And I'm thinking about smart grid here, and I'm thinking, for goodness sakes, please don't make this like programming my VCR, or I'm going to have a thermostat that flashes 12 constantly at me. And the question really, on a more serious note, is how are we working either at NIST or various companies here to incorporate the behavioral, cognitive, emotional even aspect of, I say emotional because my wife and I go round and round about what the heat should be in our home, of this technology. It's not a frivolous question at all. How do we incorporate that human behavior interface with smart grid work? Please, Ms. Stoessl.
If I may, I can give you one perfect example that one of the electric co-ops in Delaware has taken the lead on. They have a program called Beat the Peak, and it is going exactly to the behavioral element of this. They know and anticipate when peak costs are going to strike their membership, and they are looking for a simple in-home display. Right now, what the head of that utility does is literally send out an email to his membership saying, we expect peak rates from 4 to 6 p.m. this afternoon. Please curtail your usage. And his members do. And what we're now developing for him and what he's looking for is a simple in-home display, just a simple red-green kind of thing, that when that light is red, please curtail usage. Whatever you can do. Go ahead and run your air conditioner if you want, but if you can curtail, please do. And that simple indication, which will be triggered by communications through his meter and through his communication infrastructure, is a behavioral way of going at it. Very simple, no programming required, just be aware if that light's on and you can do something, please do it.
Are there other examples or comments we want to hear?
Just one comment, sir. The way the technology should be developed has to keep consumer behavior in mind and consumer sophistication. And I think that it's not one size that fits all. We must tailor the technology to the customer. So if a customer just wants to know a price and have it automated on the system, we should be able to do that. Whereas if a sophisticated customer that wants to go manipulate things just like he is sophisticated, say, on the stock market, we need to tailor the technology to meet the needs of the customer.
Is that being incorporated in the work being done by DOE, FERC, NIST, et cetera?
I'm hoping we'll see it as part of the projects that are proposed.
Chairman Baird, I would say that standards also play a key role in this, and creating a standard for customer access to energy usage information, the standard I referred to earlier for communicating pricing information, will enable the creation of software tools that can put this information in formats, on a web browser or what have you, that are easy for customers to see, or even a simple red, light, yellow indicator for customers who don't want to be that sophisticated.
We go crazy over a 50% discount on cereal boxes at the grocery store. You save your coupons and all this stuff. If somebody said you can run your dishwasher now, but it's going to cost you much more now if you run it, and back to this peak issue, it would help a great deal. Ms. Kelly, did you want to comment?
I was going to say that a follow-up to that is something that the collaborative is excited about, and it's the DOE Clearinghouse of Information. Any of the demonstration projects that receive stimulus funds will have to report information to the clearinghouse, and it's one of our goals that the consumer acceptance, which I think is another way of describing what you're talking about, is something that will have to be monitored and followed and reported so that we can understand what kind of consumer interfaces work well as what ones don't work.
That's encouraging.
Mr. Chairman. Oh,
yeah, please.
Sorry, I was just going to add that there's been a lot of work done in this area that can be translated over from internet and telecommunications technologies. And I think what you're seeing now is a lot of companies that for a long time have been developing new and innovative products in those areas moving into energy management systems. And there's a lot of work to be done there. There's some studies that have shown that programmable, controllable thermostats, about 70 or 80% of people don't actually bother to go ahead and program them. And so the new types of devices that are coming out, either portals for people to use online, in-home displays, or some are even developing it through television interfaces, what they're finding is with just simple information, rather than waiting till the end of the month on the bill, people are reducing their energy consumption 10 to 20%.
I would suggest we take a page out of the behavioral economics retirement investment models, which suggest that if you pre-extract people's retirement 401k match, you have a much greater participation than if you wait for people to opt in. And let's ship the thermostats with preset things and adjust that to some easily wireless clock reset. And then if they want, they can go with the defaults. It's a lot easier. So thank you for the insightful answers. Mr. Inglis.
Mr. Chairman, I have no further questions. I think
would you care to pass to who would be on deck? Mr. Bartlett.
Thank you very much. I was genuinely pleased at the panel's knowledge of EMP. I'd just like to note that the usual things that we say that give us some comfort probably aren't relevant here. The mutually assured destruction. An EMP blast over North Korea would have little or no effect on North Korea. They just don't have any infrastructure that would be affected by EMP. As Vladimir Lukin said, with no fear of retaliation, if it comes from the ocean, how do you know from where it came? 2 days ago, the Secretary of Defense was here, and he made the observation that they were counting on deterrence to protect us from EMP. And I said, Mr. Secretary, that's not going to work because, as Vladimir Lukin said, with no fear of retaliation, we keep watching for whether North Korea or Iran has a missile which will reach us. That's irrelevant. Neither of them. I've been to North Korea. I spent 3 or 4 days there. They may be evil. They are not stupid. They're not going to launch a missile from their soil. It's going to come from the ocean. And all one needs is a tramp steamer, $100,000 to buy a Scud launcher, and a crude nuclear weapon. You couldn't shut down the whole country with that, but you could shut down all of New England with that. And, if you missed by 100 miles, it's as good as a bullseye because it really doesn't matter. This is really a tough thing, but unless we protect ourselves against that, Mr. Martini, you mentioned that it took 2 or 3 years to get these big transformers. And that's the kind of thing that Vladimir Lukin was referring to when he said it would shut down our grid and our communications for 6 months or so. Indeed, we don't even make those in our country, do we? you order them from overseas, and so some of the smaller ones maybe 18 months or so, and some of the larger ones that long a time. And in a cascading collapse of the grid, we would expect a number of these to be destroyed, would we not?
In a very large, depending on the altitude, that, as I understand it, in terms of where it would be exploded, it could impact a much wider area, as you described. And so, yes, smaller distribution transformers, we actually have a lot of those in stock, and those can be done relatively quickly. It's the very large high voltage transformers that are essentially custom made. Those would be longer, and most of that manufacturing is not done in our country.
It's all done overseas, and you order one and they will make one for you, because these are on nobody's shelf, including the manufacturer's shelf. They make them when you order them. This is such an incredible consequence that you just shy away from it. It's old saying, if it's too good to be true, it's probably not true, and this is so horrible that maybe it's not true. But the reality is that it could be true. As a matter of fact, there's a new book out called 1 Second After, and the movie rights have already been sold to the book, and it looks at what happens in our country and their story is probably true to what will happen if it happens, and we hope it does not. By the way, if we are immune to it, it's less likely to happen. Vulnerability invites attack. But the launch comes from the ocean, and then the ship is sunk. There are no fingerprints. What do you do? In any event, what do you do when they have simply shut down your computers? And that's what it will do, just fry everything that's microelectronics. And do you then vaporize their grandmothers and their babies because they did that? It's a very difficult thing. But, if we really are prepared, it won't happen. Because if we're not vulnerable, there will be no benefit in doing it. So thank you very much for your knowledge of this, and hope you take it into account. Thank you very much.
Dr. Bartlett, my strategy in that eventuality is to come to your place.
Oh, thank you, sir. You'll be welcome.
Mr. Tonko.
The application of superconductive cable and the promises that it might hold for dealing with some of our delivery system, our transmission transmission systems primarily. Any vision as to when we might be up and ready with a superconductive application?
The discussions we've been having with manufacturers in terms of both cable and transformers in particular, it looks like if the technology is getting to a point where we can start to look at demonstrations within 3 to 5 years, particularly on transformation. We think that's a real opportunity to focus on in the near term, and which could lead to products being put into production, into our service within a decade. So we see a lot of promise there. We already have today superconducting fault current limiter that we have put in our system earlier this year, one of the first in the country, and we're working with actually American Superconductor. This was part of the award that were announced by Secretary Chu this week, a transmission level superconducting fault current limiter that will be going in our system in 2012. So we see the technology evolving, and certainly over the decade we expect to see more of this going into service.
Seems to me if we have troubles with the siting of many lines oftentimes, which traverses several communities expectedly. If we can do that with far greater capacity and the same dimension of cable, that we should really speed our investment in R&D. And I know that in New York State there are those companies who are breaking their own records in terms of development of the superconductive opportunity. So, thank you.
Mr. Tunkel, thank you. Dr. Ehlers.
in secondary schools, both before I got here and after I got here. And it continues to amaze me that I meet parents who say, well, I don't see why it's necessary. Johnny already has enough math. You know, he just doesn't. But this is a good example. If you're going to, as I suggested earlier, put digital devices on every appliance where you can also indicate the cost. You also have to have people who know how to use it and who program their thermostats and so forth. And there just has to be a basic level of intelligence and training of the American public if we're really going to make this work. I think also it's very important for the utilities. I think you mentioned that, Mr. Martini, of trained workers. And I had an experience just in the past 6 months which surprised me. My wife and I came home, turned on a few lights, and she started preparing dinner. And suddenly, some lights dimmed, a couple went out, and others were working fine. And I said, aha, we've lost one phase of our three-phase electricity. So I called the power company, and the first question, she said, are your lights out? And I said, well, some are, some aren't. And I explained to her that we obviously had lost one phase of the electricity. She had no idea what I was talking about. She said, well, we don't send trucks out immediately on a rush unless all your lights are out. And I tried to explain to her again what was going on. Just got nowhere. And so I went out of the house, went up and down the street knocking on neighbors' doors and said, please call in. She had told us that if they got more calls, then they would send the truck out. And so I knocked on neighbors' doors, said, please call this number and tell them your electricity is out. And as a result, we got the truck there quicker than we would have before. But it just struck me that an employee of the power company would not, especially one dealing with the public, would not understand someone calling in like that. So at every level, we have to have better training, including the general public, but especially your employees in the utilities. I think, Mr. Chairman, that's the end of a very, very good hearing, and I thank you for calling it and thank the panel for being here.
Thank you, Mr. Arnold. I do have one last question, and it sort of integrates much of what's been discussed, and it's this. It seems to me there's hopefully a positive synergy with the team that we see here, but you represent a much broader spectrum, and it's this. So you've got NIST working on standards, private sector working on innovative tools, electrical companies and distribution companies putting all that in place, DOE doing research. Are you comfortable, and FERC regulating so much of this, are you all comfortable that you're working together well enough? In other words, is there cross-pollination and cross-coordination? How's it going?
In my opinion, in working on several programs within the Department of Energy, this has been one of the best working groups I've had to work with.
Ms. Kelly?
We're very, very satisfied with the way things have been working.
The teamwork has been incredible with both the other agencies, federal and state level, and the private sector.
I think for utilities, we've all come together, not just regionally, but also across the nation, and working very well with DOE, the regulatory agencies, and NIST in this current effort, and obviously with our suppliers in terms of these new products and innovations that are coming to the market.
Yeah, I would just reinforce what the other panelists have said. There seems to be a great deal of coordination among the federal agencies that are involved, and I think there's increased cooperation and participation in and among industry and with utilities.
And I'll echo with the panel. I think there's always been good cooperation between the utilities and suppliers, but with this particular issue, with the government involvement that there has to be, there's been very, very good interaction, and NEMA has stepped in to really help pull industry together to give us one voice when we're interacting with the various councils, various standard bodies. We're participating on all of them. It's very important that it go forward.
Government, private sector, industry working together. Not a bad way to close the hearing. Thanks very much. Have a great day.